Action. Okay. Good evening, good day, good morning. Today, my group, which consists of Andrew, Winston, me, Dhafin, and also Hafiz, we will be doing a presentation about sustainable automatic lighting using sensors on campus. Okay, so for the content of the presentation, there will be four main parts. So the first one is introduction, and then the second one will be the reality and the solution of the problem, and then the third one is the calculation of the problem, and also the last one is about the SDG and also the impact of our solution.
Okay, so the first one we're going to talk about is the problem. Actually, modern urban centers remain heavily dependent on a fossil fuel powered grid, and every minute of the unnecessary illumination in institutional spaces like office or in classes directly translates into avoidable carbon emissions. The key issue here is that the behavioral waste neutralize the benefits of transition efforts and increase the carbon intensity of institutional buildings. And in shared environments, as I said before, campus, office, public buildings, a psychological phenomenon known as diffusion of responsibility occurs. This is the phenomenon where everyone assumes someone else will turn off the lights, and the result, no one turn off the lights, and this is a complete breakdown of individual accountability, leading to systemic energy waste. And this neglect creates an avoidable idle load, representing a systemic failure in energy management, sabotage SDG 7, which is affordable and clean energy, and SDG 12, which is responsible consumption and production. Okay, next.
So for the reality, so before we have to solve the problem, we also have to quantify. So right now, ITB, the reality is unsustainable. So we are consuming around 1 million kilowatt hour per month. So to put that in perspective, that is around 7,500 Indonesian homes. And financially, this costs around 1.5 billion rupiah per month for ITB. And there is an audit from LabTech 5 and 6, which says that the lighting that is consists of around 20 to 40%, which is wasted, and this can cause around 870 tons of carbon dioxide that is wasted. This is also the carbon footprint. So basically, we are burning money on empty rooms. So that's the reality. Okay, the next page. And so for the technical solution, we have a plan to implement what is called a passive infrared sensor and RF sensor. So we use these two sensors and implement it into our current lighting circuit. So the system operates by using timeout logic. So if the classroom is empty for let's say 10 minutes, the system triggers the off state, and so there is no human intervention that is required there. And then there is also a study from a university that confirms that using these types of sensors can reduce the classroom lighting energy by 32%. And also for ITB itself, this 30% reduction can reduce the amount of wasted money by around 150 to 200 million rupiah per month. Okay, next.
Okay, so we're going to make some calculation here, and to make our data more simpler, we focus on our analysis on only a single floor with 10 classrooms instead of looking at the entire campus, which is very hard for us to take the data. And we are going to take 10 classrooms from, as my friend said before, which is Lab Tech 5 and Lab Tech 6. And this localized approach allows us to create a clear baseline for how energy is actually used in daily academic life. And based on our observations, we know that each classroom contains an average of 10 lamps, with each unit consuming 18 watts of power, which is the average for LED. And under current ITB operational protocols, these lamps remain active for a maximum of 14 hours a day, spanning from the morning at 7 and the night until 9 at night. And when we calculate it over 1 month, this system operates for a baseline of 308 hours. So after some calculation, we get that a single floor currently consumes 554.4 kilowatt hour per month. And as Dhafin said before, if we use the motion detection systems, we can reduce classroom lighting energy by 32.4%. And after applying this reduction factor, we can save around 179.6 kilowatt hour per month. And if we convert it to money, we can save 200,000 rupiah per month. And this is calculated only per floor. The potential for campus-wide implementation is substantial. Scaling this solution across all institutional buildings in ITB will lead to a major reduction in ITB. Next.
Moving on to environmental impact, reducing energy consumption by 179.6 kilowatt hour per month directly lowers the university's environmental footprint. Based on the Java Bali grid emission factor of 0.87 kilograms of carbon dioxide per kilowatt hour, this results in a decrease of carbon dioxide by 156.25 kilograms of carbon dioxide per month. Scaling this motion sensor solution to every classroom and office campus is a direct response to the 870 tons of carbon dioxide that ITB Ganesha currently generates each month. This transition moves the university to passive energy management to active leadership in SDG number 13, climate action, by drastically lowering the carbon intensity of shared institution spaces.
As I said, we have the bulb lifespan and also its waste. Because of the on time of the bulb is reduced by 30%, it can be expected that the energy consumption and waste from that bulbs will decrease. Furthermore, the sensor technology that is implemented here can also be used to make the transition from manual switch to sensor switch easier by using the building management system. This also applies to the sensor management, or let's say the off switch time. So you can you can adjust the off time of the sensor by using the building management system. Next.
Okay. There are several SDGs that were relatable to this topic. First being SDG number 7, affordable and clean energy. Lesser energy means consumption leads to more usable energy. Okay. Second is industry, innovation, and infrastructure. SDG number 9. This allows technological development in buildings. Third is SDG number 12, responsible consumption and production. And last one is SDG number 13, climate action. with lesser pollution from energy generation and waste. Next.
Lastly, we have the impact. So the conclusion is that there is lesser energy consumption, which is roughly 30% from the manual switch. Also lesser carbon emission from power generation. That also includes the cheaper electricity bill, and this increases the bulb lifespan and lowers bulb waste, and sensors can be integrated into building management systems. Thanks. All right, that is it for our presentation. Thank you for your time and attention.